day, everyone. My name is Bakari Absalam, and here are my group members.
My name is Ogunjiro Abdusamad Gbolan.
I am Alimi Abbasit Olawale.
My name is Onifade Adeola TV.
In today's video, we will be exploring two fascinating fields of artificial intelligence: image classification and speech synthesis. These technologies has revolutionized the way we interact with machines and have found numerous applications in our daily lives. So, let's dive in. Let's start with image classification. Imagine teaching a computer to identify objects just like we do. This is what image classification is all about. It's the process of training a machine learning model to recognize and categorize objects in images. So at the core of image classification are deep learning models, particularly convolution neural networks. These networks are designed to mimic the human visual system, learn to detect patterns and features in image. And then let's talk about speech recognition or synthesis. It involves complex algorithm and model. It starts with feature extraction where the audio signal is converted into a formal suitable analysis. Then language models help in deciphering the meaning behind the spoken words. So my fellow group member here, we take turn to put you guys through on the code, and let's see if the code actually works or not.
The first step to carry out in performing this code is loading the pre-trained AlexNet neural network. The code starts by loading the pre-trained AlexNet neural network using the AlexNet function. AlexNet is a well-known deep convolutional neural network architecture for image classification tasks. The next step is read and resize the image. The code reads the Lion JPEG image from the current working directory using the imread function. It then resizes the image to the required dimension of 227 times by 227 pixels, which is the expected input size for the AlexNet using the eresize function. The resized image is stored in the variable candidate image. The next step is image classification. The classify function is used to classify the candidate image using the pre-trained AlexNet neural network function. The classify function predicts the content label for the input image and stores in the variable label. Then we display the image with the predicted label. The code uses the image function to display the candidate's image in a figure window. Then we set the title of the displayed image. The title function is used to set the title of the displayed image to the predicted label. The char function is applied to the label to convert it into character array suitable for displaying as the title. We then convert predicted label for speech synthesis. The predicted label stores in the variable label. The predicted label stored in the variable label is converted into a character array and then stored in the variable object's name. This conversion is necessary to pass the predicted label to the text. This conversion is necessary to pass the predicted label to the text-to-speech synthesis function. The next step we carry out is adding the system speech assembly for speech synthesis. The code checks if the system speech assembly is added to the MATLAB environment using the net.addAssembly function. If not added, the line ensures that the assembly is loaded for further speech synthesis. We then create a speech synthesizer object. The system speech synthesizer class is used to create a speech synthesizer object called OBJ. This object will handle the text-to-speech synthesis process. Then we set volume for speech synthesizer in the night code. The volume of speech synthesizer objects in brackets object.volume is set to 100, which represents the maximum volume level. And the last process we are going to be carrying out in this project is the speech synthesis. The speak function is used to make the speech synthesis in brackets obj pronounce the predicted label stored in the object name. This function will audibly speak out the content label predicted by the AlexNet for the Lion JPEG image.
Alright, that will be the end of our video. And thank you very much for listening.